A single number is breaking modern physics. 30 years of precision cosmology, 2 perfect answers. They cannot both be right. Physics has to choose. The gravity matrix. Today we investigate the crisis in cosmology. At the gravity matrix, we track every dataset. 2 measurements of the same expanding universe. One team measures 67 kilometers per second per megaparsec. The other team measures 73. Both checked their work. Both are right. The same universe cannot be both. Physics has no explanation. That gap is the crisis. In January 2025, cosmologists declared it official. This is how the universe proved physics wrong. Edwin Hubble noticed galaxies fleeing from us in 1929. Every galaxy racing away farther apart over time. That rate defines the universe's age and fate. For decades, physicists had a beautiful model. Lambda CDM, cold dark matter plus a cosmological constant. In 1929, Edwin Hubble proved the universe expands. He measured how fast and gave it his name. For decades, that number seemed within our grasp. Then precision instruments started disagreeing with each other. Planck measured 67, distance ladder measured 73. Hubble's greatest discovery became physics' deepest crisis. Lambda CDM had survived every cosmological test for decades. Every probe, every satellite, every result confirmed the picture. But then cracks appeared, small at first, then unmistakable. The SH0ES team had measured cosmic expansion with astonishing precision. Dr. Adam Rees at Johns Hopkins built the distance ladder. The Planck collaboration read the oldest light in the universe. Both teams worked for years. The gap refused to close. The gap is called the Hubble tension, 5 sigma wide. 5 sigma means 1 chance in 3/5 million it's coincidence. This is the discovery threshold in particle physics. The same standard physicists use to confirm dark matter exists. And to confirm the Higgs boson, that level of certainty. The teams searched for the error. They found nothing. Different stars, different telescopes, same answer, 73. Different frequencies, different methods, same answer, 67. Here's what that tells us. The measurement isn't wrong. Both measurements are correct. The universe is disagreeing with itself. Here at the gravity matrix, this result kept us up. Of all tensions tracked, this one resists every patch. In 2024, a third independent method added its voice. Gravitationally lensed quasars, time delays encoding the Hubble constant. TDCOSMO measured H0 at 72.1, not 67, not 73. A third independent team, confirming the local universe expands fast. The model survives by coincidence, or it needs new physics. Dark energy was supposed to be a constant. Einstein's cosmological constant, unchanging and permanent. DESI mapped 14 million galaxies across 11 billion years. The data says dark energy is evolving, not constant. 4-2 sigma confidence, that's nearly a discovery in physics. If it keeps changing, the universe's fate changes too. A stronger dark energy universe ends in the Big Rip. Every atomic bond ripped apart, stars, planets, atoms. The Sate tension adds a second crack to the edifice. The universe is 23 less clumpy than predicted. Every major weak lensing survey confirms this deficit. DES 6-year data, Chi-DS survey, hyper-subprime cam all agree. Here's what's puzzling: solving one tension breaks the other. Early dark energy fixes H0, it worsens SATE every time. No single patch repairs the cosmological edifice cleanly. The midpoint of this investigation demands honesty about uncertainty. Systematic error is no longer the leading explanation. Error bars still leave lambda CDM technically surviving. JWST was built to solve the Hubble tension. Sharper Cepheid calibration, cleaner distance ladder measurements. In 2024, JWST's first H0 calibration results came in. H0 73 km/s/MPC confirmed error bars smaller. The tension didn't disappear, it actually sharpened. Better data prove the problem is real, not instrument noise. We are watching cosmology's immune system fail in real time. 3 independent methods, 3 different answers, all above 67. Dr. Wendy Friedman's team measured the red giant branch. H0 between 69 and 72, still above Planck's value. The local universe is consistently expanding faster than predicted. 3 Nobel Prize caliber teams cannot explain this result. Now the question shifts: if not error, then what? New physics, something the standard model doesn't contain. Candidate 1. Early dark energy surge near recombination. It contributes 10% of critical density, then vanishes. Dr. Smith and Dr. Poulin built the leading Eta models. Eta reduces the acoustic horizon. Planck's H0 rises towards 73. But Eta then overpredicts structure. The SATE tension worsens. Candidate 2. Warm dark matter instead of cold. Warmer particles smooth out structure on small scales. It reduces clumpiness. It doesn't solve the Hubble constant. 3 solutions to the Hubble tension exist today. Early dark energy, brief surge near the Big Bang. Modified gravity, Einstein's equations may need fundamental revision. Warm dark matter, particles that suppress structure formation. Each solution fixes one crisis, each breaks another. No patch exists, the model itself may need replacing. DESI DR2 in 2025 forced cosmologists to confront this. The dark energy equation of state crossed -1. That boundary, the phantom divide, is Einstein's constant. Phantom dark energy grows stronger as the universe expands. Confirmed at 5 sigma, the cosmological constant dies. Physics would need quintessence, a dynamic dark energy field. The DESI collaboration is led from Lawrence Berkeley National Laboratory. 900 scientists, 14 million spectra, dark energy is changing. The accumulation of evidence crosses every threshold physicists set. The little red dots initially threatened the standard model further. Galaxies too massive, too bright, too early for lambdictum predictions. In February 2026, Harvard CFA offered an explanation. Little red dots are direct collapse black holes, not impossible galaxies. Black hole brightness made them appear as enormous premature galaxies. Remove the black hole bias, the standard model survives. But the Hubble tension survives. The DESI results survive. The core tension, that 6-unit gap, remains untouched. The next generation of instruments approaches the verdict. Euclid released 26 million galaxies in its first week. Its primary science data release arrives October 21, 2026. If Euclid confirms evolving dark energy, everything changes. The cosmological constant dies. Quintessence becomes mandatory physics. Vera Rubin generates dark energy and dark matter data. 800 alerts per night. Every variable star, every transient mapped. Type Ia supernovae as standard candles across billions of light years. Rubin will measure thousands of Type Ia events per year. October 21, 2026, Euclid releases its first major dataset. 26 million galaxies, independent dark energy measurement. If it confirms DESI, evolving dark energy at 5 sigma, the cosmological constant dies. New physics is mandatory. If Euclid contradicts DESI, the mystery deepens further. Either way, cosmology fundamentally changes this year. LISA will deliver the most independent H0 measurement possible. Gravitational wave standard sirens require no distance ladder at all. The merger's energy encodes its distance in the wave form. When LISA flies around 2035, a verdict comes. Here's what to watch for in the next 12 months. If Euclid DR1 confirms evolving dark energy, subscribe now. We will cover the Euclid release the week it drops. We may witness cosmology's biggest moment since Hubble. When Hubble first measured expansion, astronomers needed decades. Einstein added the cosmological constant, then called it a blunder. The discarded constant became the universe's dominant force. Now that constant may be wrong, the universe keeps revising. This is exactly what science is supposed to do. Every crack in lambdactum is a window into deeper physics. Every unresolved tension maps the next revolution's coordinates. The iron in your blood was forged in dying stars. The physics governing iron creation is what we question. We are the universe asking how fast it expands. That question, how fast, determines everything about fate. The fate, the composition, the entire history of space-time. The data is suggestive, not conclusive, that's the point. We don't know yet. That uncertainty is cosmology's gift. Since Edwin Hubble revealed the universe was expanding. What Euclid finds in October 2026 may rewrite the textbooks or confirm everything. Either answer transforms us.